So let me give you guys some more examples of logarithmic differentiation. So let's say you want to differentiate y equals x to the power 3. So normally when you differentiate this, dy by dx equals 3x squared. But let's say you didn't know this. Okay, so let's say you want to differentiate this. So take the natural log of both sides. So that will give you take the natural log of this and the natural log of this. And then well, when you have a log of a power, there's a rule that allows you to take the power outside here. So that will then become this. Okay, so normally when you're here, you normally just jump to here, log equally to both sides. That will give you this, and then automatically take the 3 down here. So this will be this, which is this line here. So normally skip this line here. Okay, so from here jump to here, and then now use implicit differentiation. Well, this here, don't forget y here is a function of x. Y is a function of x. So when you differentiate this here, well, differentiate differentiate y, which will be 1 over y, and then you're going to times dy by dx because y is a function of x here. Okay, well, anyway, differentiate this, it will give you 1 over y, but then because y is a function of x, you've got to times dy by dx. Okay, and then looking at this, don't forget this here is not a constant because there's an x here. If you're looking at something like this, then this here is a constant, but this here is not a constant. Okay, this here is a constant, this here is not a constant. Well, anyway, this here, so at the moment you've got this times this. This here is not a constant. So when you differentiate this, it will be 3 and then 1 over x. So yeah, differentiate this, it will give you this. Okay, so now when you're here, get rid of this block here. So times both sides by y. So that would then give you this. Okay, and then remember that y. Remember from up here. Hang on, we are here at the moment. Remember y. Well, when you well, y is x to the power 3. So you can put x to the power 3 in here. So this here is x to the power 3. So that, well, this here then gets multiplied to the top, giving you 3x cubed. So 3x cubed over this here, and then it gets cancelled out. So that. Well, when you differentiate it, it will then give you this. Okay, and notice that because of this x here, this power gets minus by 1. Okay, so here's another example. Let's say you want to differentiate this. Okay, so normally when you differentiate this, dy by dx equals 21x to the power 6. Okay, normally. So let's do it logarithmically. So now take the natural log of both sides. So that will give you the log of this and the log of this. Okay, and then remember this here. When you have a log of one thing times another, that's the same as log of one thing plus log of another. Okay, so when you have one thing times another, then that's the same as the log of a plus the log of b. So that's what we're doing here. So hang on, let me get rid of this. So imagine this as one thing timesing another thing here. So that becomes the log of one thing plus a log of the other thing. Okay. So basically, when you're here, take the natural log of both sides. That will then give you this. But then when you're here, visualize it as this here, one bubble times another. So now split this up. So that gives you this, and then this will then give you this. Okay. So hang on, and then so when we're here, and then what? Oh yeah, and then the power rule allows us to take the 7 out here. So that gives us 7 here and times this here. Okay, so now use implicit differentiation here. Differentiate this will give you 1 over y. Because y here is a function of x, then you need to times dy by dx. So that's the chain rule. Okay, this here is a constant. This here it's just a number. It's hang on, log 3 here is a constant. If you have log x, then this here will be this here will not be a constant, whereas this here will be a constant. In this, look at this here. At the moment, you've got this bubble times this bubble here. This is not a constant. This here is a constant. Okay, so when you differentiate this here, it will give you 0. So we'll now differentiate this. So this will be, well, when you differentiate this with respect to x, it will give you this. Okay, so hang on. So now this will, well, this will get killed off here, and then this gets multiplied to the top, giving you this. So that would then take you to this stage here, and then times both sides by y. Times both sides by y. That will give you this here. And remember, remember that y is 3x to the power 7. So now put this into this thing here. So, well, basically this thing gets multiplied to the top. That will then give you 21x to the power 7 over x. And again, because of this x here, this thing here gets minus by 1. Okay, so that's why you always get minus by 1. So, well, then overall the answer will be this. Okay.